All right, Algebra 1. It's been a while since I used this program to do recordings for classes, but you get my face and you also get the screen. The reason I'm switching to this program is because I want you to see how I'm using the Desmos calculator to find, and like our little command sheet from class, to find the standard deviation for some of these problems. So let's get to it. Yeah, the screen, we got both. All right, let's jump in. Now, the worksheet that you had, I'm asking you to do numbers 1 through 7. Now it's like, do you have the graphing calculator? What you can do is go to Desmos.com, and when you go to Desmos, go to Scientific Calculator, and you get this. You get the same calculator where you can type in and look at functions and find the standard deviation of a set. And then you type in the numbers, 2, 3, 4, 10, and stuff like that, and it would give you the standard deviation. Now, I'm going to be modeling, I'm going to be using this calculator that's off to the side, which is basically the same calculator. It just looks a little different. So, hey, I want to look at this. Here's the nice thing. As a teacher, I can copy these, and I can say, hey, this is a list, but I want to find the mean. Lowercase. I want to find the average of, and I can put all those in here, and it tells me the mean is 16.25. So 16.25. And then I want to, so I still got that list. I'm going to change the command from mean to std. Ooh, what the heck was it again? Well, you go over here to functions. Oh man, my face is in the way, isn't it? My face is in the way. But anyway, I'm looking for for the statistics function. So I'm scrolling down, looking for statistics. Oh my God, we got lots of things. I went past it. I know it's STDV. All right, standard deviation. All right, STDEVP. All right, so it's got the extra little p in there. All right, I'm going to get rid of the extra parentheses, and what do I get? I get, again, my face might be in the way here, but I get a 1.785. 1.785. Maybe I will show how we'd use this calculator here, because then my stupid face won't be in the way. Or I could go just to the screen here. Okay, so again, I'm looking for the standard deviation of, and then I'm taking these numbers. You'd be typing them in, but hey, I can copy and paste, and I'm going to do that to save time. 2.947, so we get that. So we got 2.947, and then what's the average? Well, again, same thing. I can leave those numbers pasted in, but just change this to mean, and I get the mean of 6.75. Okay, so that's how we use the tool to kind of answer some of these questions here. Now, here's the thing about interpreting it. Remember that standard deviation is a measure of spread. The higher the number that we have for the standard deviation, the more spread out from the center that the data is, and the smaller the standard deviation, the smaller that number is, the closer all the data is to the center. So here's our centers, here's our averages. That's pretty close. 128, 130, those are pretty close. But 1.2 versus a 2.6. 2.6 is a more spread out set of data. All right, so it says Moon and Alejandro both are on the track team. Each day in May, they record their average distance that they threw the javelin. Oh, there you go. So this is their averages, okay? But based on the data, they would have done this for multiple days, and then they take the standard deviation. What does this mean? This means that who's the more consistent thrower? The one with the smaller standard deviation. So this is the great thing, is that without even seeing a graph, this number tells us that the data is more consistent for Alejandro. If a throw of 160 feet was added to each data set, whose standard deviation would change more? Now that's interesting. 160 would be further away from both of these centers, since Moon already has variability. More variability than the other one. It's going to affect the variability of Alejandro more than Moon, likely. So whose would it change more? It would probably change Alejandro. So let's move on to the next one. So problem 5, where is it? Oh, okay. I'm going to zoom out a little less. Okay, so Brumfies, it says, order the data sets from smallest to largest standard deviation. Use a calculator to help your thinking. Okay, so that what that's saying is that we're going to order these. We could take these numbers, type them in the calculator, and find their standard deviations. That's kind of what we should do. So we have a 7, 10, 12, 14, 17, 19. So I'm going to go escape out of this, go back to my scientific calculator, get my standard deviation prompt, and I got to change my numbers. All right, so what were my numbers again? It was a 7, 10, 12, 14. So 7, 10, 12, 14. I feel like there was a 17 in there. I'm going to just put it in for now. Let's see. Yep, 14, 17, 19. 17 and 19. Standard deviation of 4.05. So I'm going to remember that. All right, so I don't know. 4.05. That's horrible, but whatever. It's good enough. Next one, 225. Oh, those numbers are really far from whatever the heck is in the center here. Okay, so 225, 22, 25. Okay, so I can go back here. You guys see how this is? It's just 2, 5, 22, 25, and 25. Standard deviation of 10.59. We knew. So 10 point something, 10.59. This one's really high. So smallest standard deviation. This one's now, I definitely know is pretty high. Let's see. It's probably not, this one's probably not as high as that one. 4, 8, 9, 10, 12, 13. Those all kind of seem to be closer. I feel like that one might have the least. 4, 8, 9, 10, 12, 13. 4, 8, 9, 10, 12, 13. 13. Okay. 2.92. Okay, so we get a 2.92. Now that one is now the smallest. So that one, the numbers are smaller. Closer to the center. This one's a little further spread apart. These are really far spread apart. This is like bimodal. You have really lows, you got really highs, nothing really in between. Bimodal ones will have a high standard deviation. All right, a lot of spread, a lot of variability. Now, let's see, problem 6 and 7. You're welcome. These are the last two that I definitely want you to be able to do here. Yeah, okay. So here are the high temperatures in Seattle for each day in 2021. If the data points for the hottest and coldest days are removed, would the standard deviation increase, decrease, or stay the same? So let me. All right. So if the data points for the hottest and the coldest day, so if we remove this chunk and this chunk, would the standard deviation increase, decrease, or stay the same? What is standard deviation? Is a measure of spread. How far spread apart is the data here from the center? Well, if I'm removing these, getting rid of this data and getting rid of this data, that brings everything closer to the center, and the standard of deviation will shrink. It'll get smaller, so it will decrease. All right, that's definitely a big learning target today, is knowing how to interpret that. So here's a data set, 4, 5, 6, 7, 9. Those are all pretty close together. If we, middle value. So the average seems to be like it's going to be somewhere, between 5 or 6 or somewhere around there. All right, select all the changes that will make the standard deviation smaller. So we want all the changes that will bring things closer to the center. For the heck of it, 4, 5, 5, 6, 7, 9. Let's do 4, 5, 5, 6, 7, 9. I don't want the standard deviation. I want the mean. All right, so we could use the calculator. Here's what I want. What did I want to do that for? I wanted to find the mean so that I knew what was our center and which number are we going to be moving closer to. So if we added a 2, would that move our standard deviation closer or further from 6? It's going to move it further away. That's not one of the ones to pick. If we added a 6, that's going to be one more data point in the middle, which is going to bring the standard deviation closer to the middle. So that would make it smaller. If we removed a 4, yes, that would make the standard deviation smaller, because if we remove the 4, we're removing one of the numbers that's farthest from 6, thus pulling everything back together. If we removed a 9, that would also pull us closer to the center. If I increase each value by 10, now that's an interesting one. So that's saying, what if we had a 40 and a 50 And oh my, I can't draw all these, but what if we had a 40, 50, 50, 60, 70, 90? Here's the thing, if we did that, that's an interesting thing. So let's go, let's see what happens on the calculator. Sorry, if we take these numbers, use the standard deviation command to find the standard deviation. But now all right, 1.6, let's just see what happens. Let's put a 0 at the end of these. Oh, no, it said increase it by 10. So that means to turn them into 14, 15, and 16. My prediction is that the standard deviation would be the same. There we go. Because we're increasing them all by the same amount. So the center is still staying in the center at 16 now instead of 6, but it's still like the same value. So that would not make it smaller. That would just leave it staying the same. All right, folks. Hope that made sense. Yeah, just ending the video here. I hope that made sense. Take care. Bye.